I'm going to show you how to do a collet slip test. It will tell you how much torque is required to cause your workpiece to slip in the collet, which obviously destroy the part or make it useless. Hook up a digital torque meter. We have a hex milled onto a piece of round stock. That specimen will be grabbed by the collet. We'll just be able to put our wrench, lock the spindle, give it a crank, and let the torque meter tell us. We'll push until we feel it to slip, record the torque. I found it's best if you use a digital torque meter that will report the maximum torque value. You won't have to constantly monitor as soon as it starts to slip. You can let go of it and just read the number that's frozen on the screen. If you have a digital torque meter, only beeps whenever it gets to a certain torque rating. That might be more difficult. Alright, so the important thing here is you need to be able to tighten it down to the same drawbar tension for each trial if you're doing in order to make it consistent. So if you're just doing one trial and you're just curious how many foot-pounds is required to make it to slip, then I guess that wouldn't matter. If you have a hydraulic drawbar, then you could set it to 200 psi or whatever. Use the same pressure for all your trials. Okay, so what I'm just going to do is use the flat of the hex as a reference. So I'll turn it to there, and then maybe one more right here. So I'll always turn it so that this flat face is like parallel to the front of the machine. So the specimen is locked in there, and let's just get an idea of how much torque is going to be required to get this to slip. So the spindle lock is in its key, and I'm gonna... Okay, it's 40.6 foot-pounds. Obviously that number will increase with the drawbar tension. However, if you were going to try, say you bought a serrated collet and you wanted to know how much improvement that is, it doesn't really matter what your drawbar tension is as long as you repeat the trial at the same tension. 100 psi on your drawbar, you would want to make sure that you use the same 100 psi for both tests. So the other thing that you have to know about this type of testing is as the workpiece starts to slip in the collet may begin to dig in and build up a little bit of the material that's being removed a little bit from the sharp parts of the collet. They're going to get pushed out of the way and maybe mound up a little bit. Anyway, what I'm saying is, contrary to intuition, it's better if you do it kind of quick and don't sit there and slowly ramp up and ramp up and ramp up the pressure, because you want to take the reading as soon as it slips. Oh, the other thing is, whenever you do multiple trials, just keep doing this. You're always going to get the same number, so there's really no purpose in doing that unless you take the workpiece out and rotate it a little bit. And that would probably be even more important if you were testing a serrated collet, because your workpiece could develop little indents where the serrations are, and you don't want to be, you would skew your numbers if you continually dig deeper into your workpiece. Alright, so 22.6 foot-pounds, and that's a lot lower than 40, but that's why you do several trials. Sometimes it's just a matter of the technique of how you do it. Just try to be consistent, just like that. 20.5. So now I'm getting pretty consistent readings. I'll do a third reading. A reason that you would do this is if you're having slippage problems and you're trying to determine, okay, what options do I have? Do I need to buy a serrated collet? How much better is a serrated collet? 21.1. We got 3 readings in a row that were about 20 foot-pounds. Well, now that we have a way to test the slip torque, we can put the collet in different conditions and see what happens. So I'm going to take some grease, this is lithium grease, and put it on the taper of the collet, and that is plenty of grease. So I'm not putting it on the inside of the collet. Obviously that would cause the workpiece to slip a lot more easily. It would reduce the friction on the clamping surface. This is going to behave a little bit differently because this is actually lubricating the taper surfaces, and in theory that would allow the taper to slide in farther or with less friction. But the question is, will that actually improve your clamping force at all? Important that you don't get any grease through the slits into the inside, because that would definitely skew the results if it got onto the workpiece. So I'm going to insert this sample and then take it to as close as I can, and that already feels like it required less torque to get it to this position. I think that actually means that the grease made it slip into the taper easier. So let's go ahead and see what effect that had on the slip torque. 14.2. So before we were around 20. It could be that this is not exactly where we had it before. But remember, I loosened and tightened this down 3 times, and I got about 20 foot-pounds each time. So that we probably are seeing the effect of. Now I'm going to take this out and just look for grease, but we'll do another trial and see if it's like the one before it. .2 real quick. See what the third trial. And 11.1. So you can safely say that if you get grease on either the inside of the collet or the outside on the taper surface, you're going to drastically reduce your clamping force. So in case you didn't know before, you want to keep your collets dry or degreased. In conclusion, if you are having slippage problem with your collets, you can use this method to kind of experiment and determine if what you're doing is helping or hurting your slipping force. So thank you for watching.